Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on discrete distribution, population mean and standard deviation, and expected value. And we are doing part 2 of this series and picking up on the population variance. You may need to watch part 1 of this series where we started this example and found the mean of the population mean of this table. But we're going to just pick up where we left off to find the variance. We will need to remember that the variance measures, what the variance measures, and we will start by looking back at our graph. The variance is a measure of the distance of the data values are from the mean. For the variance, we will use signed differences from the mean. In other words, we want to measure how far each of the numbers are from the mean. And to look at the graph, each data value is a distance from the mean, and we find that signed distance by simply subtracting. Let's look at a bigger picture of that and each data value separately. Remember that the mean for our data was 11.4. Our first data point is 10, and the distance from 11.4 can be found by saying 10 minus 11.4, and the signed distance is negative 1.4. Moving to the next data value, 11, the distance between them is 11 minus 11.4, and the signed distance is negative 0.4. Moving to 12, we get 12 minus 11.4, and the signed distance is 0.6. Next, we have 13 minus 11.4 as we look at the data value 13, and the signed distance is 1.6. So we have all of our signed differences. To find the population variance, we have 4 steps. First, to find the signed distances from the mean. Next, square each signed distance. Next, after that, multiply by the probability or the percent. And lastly, to add each of those values together. The second step, squaring each signed distance, we do this to make all of our values positive. We multiply by the probability or the percent because remember, for example, 20% of the time we would get a signed difference that went with the 10 of a negative 1.4 and so forth. And lastly, we add up all the values because we're interested in all the data values. So here are our calculations. %20 of the time we get this signed distance squared. 10 minus 11.4 is the signed difference squared, and we get that 20% of the time. Our next data value is 11. The signed difference squared, and 30% of the time we get this signed difference squared. Distance, excuse me, not difference. Next to the data value of 12. 12 minus 11.4 squared. 40% of the time we will get this signed distance squared. Moving on to data value number 13, we get 13 minus 11.4 squared, which is the signed distance squared. And 10% of the time we get this signed distance squared. I think that's a tongue twister. Okay, so find the signed distances from the mean, and that's highlighted there in yellow. Square each of the signed distances. That's highlighted in pink. Multiply by the probability or percents. That's highlighted in aqua. Add. That's pointed to there with the red arrows. And that's our 4 steps. Now to develop the formula. And then doing the arithmetic, it gives us that the variance is 0.84. Our population variance. Now to develop the formula for our variance. And here's our formula. The variance, population variance, equals the sum, because we added, the x minus the mean squared, which is the signed differences squared, times the probability of x. Find the signed distances from the mean, that's the x minus the mean. Square each signed distance, that's the squared. Multiply by the probability of the percents, and then add together. So the 4 steps are shown in the one formula. And if you'll remember your 4 steps, finding the variance will be much simpler. Does this match what we did before? Yes, and the answer to this calculation is 0.84. Our task for this example, our last task for this example, is to find the population standard deviation. We have the population mean to be 11.4, the population variance to be 0.84, and now we need the population standard deviation. The standard deviation is the square root of the variance. So we get the square root of 0.84, which is approximately 0.9165. And that is our population standard deviation. And now to develop the formula for that, we just want to remember that it's the square root of the variance. So to summarize our 3 formulas, well, let's not click all the way through at once there. To summarize our 3 formulas, for the mean, we have the sum of x times p of x. For the variance, we have sigma squared equals the sum of x minus the mu quantity squared times p of x. And for the standard deviation, the population standard deviation, we get sigma equals the square root of sigma squared. And this is a good place to stop the video for part 2. And to conclude this part, I will pick up right where I left off and continue in part 3. If you are a Walter State student and need additional help, you are welcome to come by and see me in MBSS 222 in the Math Lab. Thank you for watching.